All right, today we are diving into something really special. A brand new window on the universe called the Vera C. Rubin Observatory. And let me tell you, this is not just another telescope. It's more like a cosmic movie camera, and it's named for an absolute giant of an astronomer who completely changed how we see the universe. So, to really get this, we have to start with a mystery. A huge cosmic question that had astronomers scratching their heads for decades. And it's this: why don't galaxies just fly apart? I mean, it sounds weird, right? But this was a real problem, called the galaxy rotation problem. See, when astronomers looked at the stars way out on the edges of galaxies, they found something that just didn't make sense. These stars were moving so fast, way too fast. Based on the gravity from all the stuff we could actually see, the stars, the gas, the dust, there was no way they should be held in orbit. They should have been flung off into the void ages ago. So who figured out what was going on? Well, that brings us to the hero of our story, the absolutely brilliant and unstoppable astronomer Vera Rubin. It was Vera Rubin's work, her incredibly careful and meticulous observations, that gave us the first solid, persuasive evidence for this invisible stuff we now call dark matter. She was the one who measured the speeds of these stars and proved, beyond a shadow of a doubt, that what we see is not what we get. There had to be something else out there, some unseen mass providing all this extra gravity that holds galaxies together. And you have to understand, her path was anything but easy. In 1948, she was the only astronomy major to graduate from Vassar. The next year, she tried to get into Princeton's grad program and was flat out rejected simply because she was a woman. But did she stop? No way! She got her PhD with a thesis so ahead of its time, it was considered controversial for 2 decades. And get this, it wasn't until 1965 that she was even officially allowed to use the big telescopes at the Palomar Observatory. She was a true trailblazer. And this quote just says it all about her, doesn't it? Don't worry about prizes and fame. The real prize is finding something new out there. It was never about the awards for her. It was always about the thrill of discovery. So how do you even begin to honor a legacy like that? Well, you build a revolutionary new eye on the sky, one that's designed to carry her quest forward. And here it is, the Vera C. Rubin Observatory. It's sitting high up in Chile's Atacama Desert, one of the best places on Earth to see the stars. And its whole mission is basically to tackle the very questions that she first brought to light about our invisible universe. And this thing is an absolute beast. Its main mirror is a massive 8.4 meters across. That allows it to just drink in light from the most distant corners of the universe. And its camera? Forget your phone. This is the world's largest digital camera, coming in at an unbelievable 3.2 gigapixels. The detail it can capture is just staggering. All that power means it's going to produce a mind-blowing amount of data. We're talking 20 terabytes of images and information every single night. That is a fire hose of cosmic data unlike anything we've ever seen before. Now, I know what you might be thinking. Hey, what about the James Webb Space Telescope? It's a great question, but Rubin is a totally different kind of machine. It's a survey telescope. Think of it as that cosmic movie camera, not a deep dive microscope. Okay, this is the most important thing to get. The Rubin Observatory is like a movie camera for the sky. Its job is to take a picture of the entire southern sky, and then do it again and again and again, looking for anything that changes. The James Webb, on the other hand, is like a cosmic microscope. It stares for a long, long time at one tiny specific spot to get an incredibly deep, detailed picture. And you can really see those differences here. Rubin's field of view is huge, while Webb's is tiny. Rubin is on the ground, Webb's way out in space. And that data rate, look at that, 20 terabytes a night for Rubin versus around 57 gigabytes a day for Webb. They're built for completely different jobs. Rubin can whip around to a new part of the sky in 5 seconds, Webb can take up to an hour. Wide and fast versus narrow and deep. But here's the beautiful part. They're not competitors. They are partners. They're a team. Rubin is going to be the ultimate discovery engine. It'll flag millions of new and interesting things happening in the sky, and then we can point our powerful microscope, James Webb, at the most exciting ones to get a closer look. It's a perfect partnership. So what's the grand plan? Well, for 10 years, Rubin is going to conduct what's called the Legacy Survey of Space and Time, or LSST. Its job is to chart the dynamic, changing universe in a way we've never, ever been able to before.
And the method, what they call the Rubin cadence, is just beautifully simple. Here's how it works. 1, take a picture of a huge piece of the sky. 2, just wait a few nights. 3, take a picture of that exact same spot again. And 4, let some incredibly powerful software compare the 2 pictures and automatically flag absolutely anything that has moved, brightened, dimmed, or changed in any way.
And how many changes are we talking about? The observatory could generate up to 10 million alerts every night. 10 million! Now sure, most of those will be things we already know about, but hidden in that torrent of data will be exploding stars, asteroids zipping past, and maybe, just maybe, completely new kinds of cosmic events we don't even know exist yet. The scientific goals for this 10-year mission are just, well, monumental. The LSST is going to create a new map of our Milky Way. It's going to catalog 17 times billion stars and 20 billion galaxies. It's going to find millions of new asteroids, track exploding supernova, and to bring it all home, it's going to give us the best data we've ever had to finally pin down the true nature of dark matter and dark energy. Which, of course, brings us full circle, back to a remarkable legacy and a scientific quest that is far from over. Because, you see, this observatory, it's so much more than just glass and steel and electronics. It's the living, breathing continuation of Vera Rubin's fearless curiosity. It's the next chapter in her relentless quest to understand the invisible universe that she first showed us was there.
It took decades for the world to fully catch up to her groundbreaking work. But now, this incredible machine bearing her name is about to open a new era in astronomy. And it leaves us with one thrilling question. What secrets of the dark universe will her legacy finally uncover?